We are continuing with solving neetcode. So we are given an integer array of heights representing the histogram bar height, where the width of each bar is 1. Return the area of the largest rectangle in the histogram. Okay. So we are given an array of integers of heights, and we have to return an integer, the maximum area of rectangle histogram. Okay, so we have here. Then let's create test cases. So we have first test case, for example, this one. So what we can see here, we have different heights, and we can check that, for example, height from 2 to 3, right? It would be with minimum 2 multiply by 1, 2, 3, 4. So it would be 8, right? It would be 8 rectangular is in histogram. Okay. Rectangle, it can be like this one or this one. Yeah. So here we can calculate, yes, the histogram, and then if it will like, yeah, we can just move first, for example, this one, then we have 1, it's less, then we have 5, and we have 3, and with 3 multiply by 1, 2, 3, 4. Yeah, actually 3 we can multiply. No. So the problem here is that we have 2, so we actually cannot calculate it. So what we need to do is, yeah, we should find the minimum here. So for example, this one we also cannot take 2 because we have here 1. So it means that 1, it would be the like rectangle, the minimum rectangular that we can take from here. So but when we move here, it would be 2. Yeah, so it would be something like this. And yeah, so let's ask some questions. So what would be the length of our array? So I expect that it can be like from 1 to, let's say, 10 in horsepower. Also, our values should be from 1 to, let's say, I don't know, 10 in third power. And do we have something else? No, we have like here, yeah. So it would be in 5 and here in 4. Okay, cool. So actually we cannot solve this question as we see with quadratic time because it would be 10 in 10 and quite a lot. So we need to have something better, and I believe we can do this. So what we can do actually with this array. So with this array, we can understand if we own one value 2, it would be 2, the minimum number. But if we take the range between 2 and 1, right? So here it would be 1. This 2 becomes 1. And all other becomes 1. But from here, 5, it becomes greater than for 6, 2, and 3. So I'm thinking like, how can we actually calculate our rectangles here. How can we utilize stack? So for example, we have some stack, right? So we put 2 on the stack as our starting position. Then we can take 1 from the 1 to the stack, right? So we have some, let's say, result, and our rectangular would be 2 at the beginning. Then we have 1. So what we can do, we don't only put 2, but we put 2 with index. Then we have 1, and 1 is less than 2. So it means that we need actually to calculate this value and to skip and to calculate result. And the result in this case, it will be 1 minus 0 plus 1. So it will be 2 multiplied by minimum. So we also have some minimum. It was 2, but now it becomes 1, right? And yeah, so maybe we actually don't even need this index because we can take stack length. So we see that value is less than minimum. So we can calculate, just multiply by stack size plus 1, and it would be again 2. So we just take everything from here and yeah, we can take everything from here. We can have 0. So this one is not correct. We can have 0. So when we on 1, yes, I think we could skip here. And then we move to 5. We move to 5. Our minimum becomes 5, right? Our minimum becomes 5. We put it. When it's greater, we put 6, but it's still 5. Then we have 2, right? And 2 now is less. So, and all the time here we can calculate, like we have 5, so result becomes 5, right? And then we put 6, and result becomes 10. And now it's 2, so we can calculate. So we are taking 5 to multiply by 3, 6, not greater. So we have 2 here. We actually, I think, can put 2 maybe. And then we go here to the 3. So we have to multiply by 2, 4. Yeah, but I'm not pretty sure about all these calculations that we have here. Yeah, I'm not sure. So when we should take it out, so we put 2, then when we have less values than this one, we should take, yeah, actually we should take them all. But here we have different stations. For example, if I want just to calculate all, like, should I take them all? Should I take them all? Yeah, let's think about other scenarios. So, can I something like, if I take this 2 and I like go here, it becomes all ones, right? Then I take 5, it's 6, and then 2, it becomes all 2s. Then you have 3, but I don't check the whole, for example, the whole my array, so it's a problem. Also, I didn't check some parts of this array. So for example, I don't know, this part or this part, but I need to check all parts here. So how can I work? How can I work here? So when I'm on some element, for example, I'm on 2, and can I ask some data structure, and this data structure actually should return me the minimum number in different ranges, actually in this range, and also in this range, and yeah, in this one, like in different ranges. So I can, like, definitely I can solve this this task in quadratic time for sure, because I just can calculate and just go from, I start from here and just calculate all possible values, all possible scenarios. But here I need to use some half stack. I need to use some half stack. Let's create different use cases. So for example, if I have 1, 2, 3, 4, then 1, the results here, it should be 3 multiplied by 2, I think 6, or 2 multiplied by 3, it's also 6, or 1 multiplied by 5, it would be 5. Okay, so here it's actually 6. Here it's 6. Okay, yeah, so I think that what I can do here, maybe it's like 2 pointers. So first it's 1, right? Then I put all these values, and I calculate that 1 multiplied by 4. So it would be 4 here. But then when I reach this 1, I should start moving here, and I should calculate all these positions. So it means that when I calculate this 2, 3, 4, I need to remember. Somehow this 2, 3, and 4, like the minimum value here. And here it would be 2. But how can I know this minimum value? Because for here I just know 1, right? I just know 1. And I put 1, 2, 3, and 4. Maybe I can just store in stack not only value, but also minimum value. So for example, when I store 1, it would be 1, right? Then I have 2. It would be 1. So I can take this 1, and I have 2. But here it can be like, no, it cannot be like this, right? Because in this case, yeah. So yeah, I think it should work, because in this case, I put all values, and then I recalculate them one more time. So here, what I do, like I iterate, I calculate, and now when I have this situation, I should recalculate for all possible values. And I calculate, and then I like reach this 1 once again, and it would be my minimum value here, again 1. And then yeah, I calculate one more time. So I think it looks like 2 pointers. So let's try to implement it. So I have our result, and I have something that is iterating all the time. Hates length I++. So, and here we have our minimum 0. And here we actually can start from 1. No, we should start from 0. And here we return a result. And let's start from, yeah, let's start from here. So while let's say like this. So if we have int j, let's say, and yeah, and here while loop, while let's make it r for simplicity, while r on j is, so like this in this example. Yep. So this would be our j, and this would be our I. So we increment I. Yeah. Because yeah, it's greater than previous. and then we increment to 1. It's not greater than previous, and it means here we have like minimum value. We can start iterating. And here, like, we can just check if array length is equal to 1. We just return array 0. Here we can start with 1, and we can check while our I is less than our I minus 1. Now if we can check like this. So if it's like this, if situation is like this, so if r minus 1 is greater than ri, we should do this while loop while we move our j is less than I. And we actually do this move and we calculate our minimum, update our minimum. Actually, we even don't. Do we need minimum? Yeah, let me think. Do you need this minimum? Minimum would be always on j. So what we do here, we can just update our result, I think. Let's do like here. So we start with this one. So we see that this one is greater. So we have j, and yeah, so what we can do, it's actually we can calculate. So first we can calculate our result, mass maximum between results, and currently I is like this. So we can take yeah, first of all, what we can do, we can like mass mean between array I and array j, and it will be full pass, and we can like multiply this by length. So it will I minus j. Yeah, so it full pass that we can take. Also current value array I, array j, because when we go here, we just multiply, multiply, multiply. And then when we reach this one, we have this full path. So we multiply by full path. And yeah, so we multiply by full path first. Then we take current J, and we can take like mass maximum from this two. Okay. Mass maximum from this two. I think we can do it like this here one time. Sorry. Yeah, so what we can do here one time this full pass. Then here we should calculate this binding. So we take I minus j minus 1. And here we take array I multiplied by this length. And then we increase our j. Okay, and here else, what we do in else, we just should increase our result. So here we have the situation when next value is greater. So yeah, next value is greater, so we just take array j and we multiply by j minus I and do like mass maximum like this. Something like this. Let's run. What? Cannot find symbol. Array max. Mass. Okay, yeah. Mass. So let's first debug this example with our code. What do we have here? All right, so we have results, minimum, I think, yeah, we don't need. So we have results, we have j, and what we do, so we start with 1, and 1, yeah, so we go here, then we go to mass, we have result, that is 0, then we take 2 maximum. First maximum would be, yeah, the minimum between these two is 1, and multiply 1 minus j. Yeah, so here I think it should be plus 1. So here it should be 2. And also we take just current value of j. And I think this current value of j what we actually can do is, I believe we can put it here. So first it should be like result maximum between results and rj. Yeah, and here we should just take this out. This we should remove, do it easier. Yeah, so we calculate this pass first. And yeah, and then while j is less than I, we also take result 2 and this 2. So here it's still 2. And then we take result of j 2, right? And yeah, so we iterate it's I minus j, it would be 1, minus 1, 0. And here, I think if this one equals 0, then 1, otherwise this value. Yeah, and I think this we should then skip. Yep, and then we just iterate. Okay, so here we have 2, yeah, and we iterate j to this one. And then becomes equal. So after they become equal, then we have 5, right? So 5 is yeah, so 5 is greater than the previous, so we go here, and here we have a result that is 2 now, and now yeah, now we have 1 multiply by j not minus 1, but I think j minus I, and here it would be 1. Yes, so we should have 1 here, then we increase 6, and now when we have 2, we should start decreasing. So first we actually calculate like 1, 2, 3, and 4, so it would have 4, and then we start moving this value 5, and here it should be 5 multiply by j minus I minus I. Here j on 0, 1, 2, 3, 4. So 4 minus 2, 2. 4 minus 2. Yeah, so here we calculate. Let's see what we have here. We have 2 and 4, yes. So, and in result, we actually, what we should do, when we have such situation, we also should calculate the whole hour value. So here we check if I is greater than j. That means that yeah, we don't have I, right? So if j is less than array length, so we should do here like the final calculation, and here should be array length, and here it would be not I but array length, yeah, sorry. And here we need to run one more time. And let's try to submit. Okay, so we have 2, 1, output is 2, but maximum here, as we see, is 1 multiplied by 3. Yeah, so I believe we still need, we still miss some parts. And I think that if we will do like just one minimum so yeah, so what we can do, we just can when we iterate through all our array, we can do like this. So array 0, and then we just iterate mass minimum over min and array I, and here we can do like min is greater than result, than min, revised result. Yeah, we can use this use case. It's for all. Sorry. Min multiplied by array length is greater than result, then we just can do like this. Yeah, so we still have some problems here when we have 5, but actually it's more. So I believe, yeah, I believe submissions, like solutions with 2 pointers, do we have here? 2 pointers. Okay. Let's try to see. It's something we have with 2 pointers, but see that it's much more complex. And it's not a lot of them. So most of them is like stack options. Yeah. Yeah, we need to find something that is not new. Let's go to all 25. Yes, maybe this one. Okay, so I think this one is good. So we have our stack, we push -1. We iterate over our array while stack not equal 1 and height is less than peak height. So yeah, so the same logic here. We pop height, we take this and we push, and while peak, okay, height. You look like the same as we did. So maybe something that I miss here, some very simple case. But actually, it looks like for me is a stack, but yeah, let's stop here for today. Thank you. We didn't solve it.